Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial, and we have specific processes under specific results. Then we end it. Let's start with this polynomial. This is a trinomial expression, and based on our guide, we need to start with the common monomial factoring with regards to the common or the greatest common factor of all these three terms, and then we need to examine further if the resulting trinomial later, after taking out the common factor, can be subjected into further steps. So we are going to use the common monomial factoring here first. But since, if you have noticed, all the numerical coefficients are in terms of 1. The first numerical coefficient is 1, the second numerical coefficient is a negative 1, and the third numerical coefficient is also 1. That would mean that we cannot create other common factors for the numerical coefficient aside from 1. Or better yet, let us no longer take a common factor for the numerical coefficient, and let's focus on the literal coefficients. When we talk about literal coefficients, we are going to look at the variables that are common to all these three terms. And aside from looking at the variables, because all of these three terms has m's and n's, we are going to look at the exponents of these variables. Why exponents? Consider m. M here is m to the power of 4. Here m cubed, and here is m squared. All of these are with m. If you're going to factor out m, the remaining m here is m cubed. For the second term, m squared. And for the third term, it's m to the power of 1, or simply m. We can still further factor out another m here. And you're going to do the same process, so on and so forth, if it's still possible. My point here is this: when you're going to take a factor of any literal coefficients or variables that is present in all terms, look for the lowest or the least value of the exponent and take it out. Here we have 4, 3, 2. We're going to factor out 2. Why? Because the first term, m to the power of 4, is m squared times m squared. For m cubed, it's m squared times m to the power of 1, or simply m. And here you already have an m squared. So you can factor that out. Next is for n. We have here n cubed, n to the power of 4, n to the power of 6. The same thing will be applied here. So we are going to factor out n. Of the lowest value of the exponent, it's n cubed. Okay? N cubed. Because that's the least. 3, 4, and 6. Because this is, of course, n cubed. This is n cubed times n to the power of 1. This is n cubed times n cubed. So all of these are present in all of the terms. And then we can continue factoring them. So let's do it like this. Since you have here m squared and n cubed, we're going to factor out here. What remains here is just m squared. The entire n cubed is factored out. You can always check that using distributive property, and you will see that it will return to m to the power of 4 if you're going to do that. For the second term, minus, you will have here m to the power of 1, because this is m squared times m, and n, because this is n cubed times n. And finally, for the last, you will have plus, m squared is also gone, you will have here n cubed. Okay? So that's 3. Again, you could always check using distributive property. M squared times m is m cubed, n cubed times n is n to the power 4, as well as here, and you will get the same results or the original polynomial. That would mean your answer is correct. After this, since we are done with the common monomial factoring, let's examine further this trinomial. Now, if this is a trinomial, there are 2 possible scenarios, or I guess it's a 3. So let's consider the 3. The first scenario is that this is a perfect square trinomial. The second scenario, this is a factorable trinomial. And the third scenario is to stay as it is. To examine whether this is a perfect square trinomial, these conditions must be met. First, the first and the third term should be a perfect square trinomial. A perfect square rather. So you have m squared is yes, a perfect square, but n cubed is not. So we still have another condition for the middle term, but since the third term doesn't satisfy the first condition, this is not a perfect square trinomial, so we cannot go to that direction. Let's proceed to the second direction. Is this a factorable trinomial, aside from it being a possible perfect square trinomial, to which we already checked earlier that it's not? This is not a factorable trinomial because it should follow the concept of your third term could have a different factors. You're going to look for factors, and if you're going, or the numerical coefficient rather of the third term is 1, and the factors of 1 is 1 and 1, or -1 and -1. None of those pairs when added will result to -1. So this is not a factorable trinomial. In short, we go to the third scenario. Take as it is. This means that our factor earlier, after taking out the greatest common factor, is ready the answer here, and this is how we factor this trinomial. The next factor we're looking for is for our next subscriber. Subscribe now!